All right. Welcome, everyone. Thanks for coming to this Thursday session. We are almost there. So today, my name is Yuyang, and together with two of my colleagues, Tim and Michelle, we will talk about sustainability topic today. So since it's late, I'll start with something fun. Yesterday, just for fun, I Googled how to be sustainable. And the result is quite shocking to me. The first thing that popped up is eat less meat. I was like, oh, I'm sorry, what did I do? I shouldn't have gone to Costco and bought that 20-pound steak yesterday. And there's obviously more things like, buy organic food, drive electric cars, walk more, drive less, and all of those kind of things. And the last one is think twice before you buy stuff, before you go shopping. And I was like, okay, yeah, I can definitely think twice. That's the least I can do, right? Buy it today or buy it when it's on sale. So yeah, joke aside, I think obviously and clearly there's a lot of different understandings about how to achieve sustainability, how do you define sustainability, and what is the most effective ways of achieving sustainability. This is at individual level, it is also at company level, right? And also on top of that, there's a lot of motivations that, I guess a lot of different motivations when people think about sustainability. Some people really believe in the cause. Someone do it because they have sustainability in their job titles. And someone just, at the company level, there's maybe financial and tax incentives and benefits. So when you put everything together, there's so complicated a problem to solve. Last year at OCP, they put sustainability at the 5th tenet. I think it's a very important step in order to gather more attention to the topic of sustainability. And I think one thing hopefully you all agree with me, is actually two things. One is, why do we need to be sustainable? Because we all want to leave this world a better place in 10 years, 50 years, 100 years, better than the world we live in today for our next generations, for your son, your daughter, your grandson, granddaughter, and their son and grandsons in the future. And also, I think, I hope you agree with me, is we have to start somewhere. It's a collaborative effort. Everybody have to do their share. And everybody can do a little bit to help improve the process. So with that, I'd like to, instead of eating less meat and think twice before go shopping, let's address this sustainability problem from a storage perspective. The topic for today is to rethink the swimlanes for sustainability, learning from SSD evolution. We are from Solidigm. Solidigm is a leading SSD vendor in the market. So what we're gonna talk today is, first of all, we're gonna share the evolving SSD requirement in terms of density and endurance. And we're gonna share some sustainability drivers and real life results with you. And hopefully that will inspire you as a architect in the data center or analyst or whatever you do about how we better improve sustainability from the storage perspective. Then I'm gonna pass it to Tim to talk about the cooling cost savings with extended temperature and power performance trends over time. Then we will conclude with a call to action by Michelle. I will start off with our two main takeaways. Number one is we believe having a larger density SSD will help you optimize sustainability in the data center. And secondly, we believe that running the data center or SSD a little bit warmer will improve sustainability significantly as well. So without further ado, let's delve into that. First of all, density. You know, everybody knows nowadays data are exploding with the advance of technologies and also digitalization across the board. Here are a few examples of on the edge for autonomous driving. There is a massive amount of data being generated every hour. You can see here it is between 1.4 terabyte per hour to 19 terabyte per hour that accumulate to almost 5 petabyte per year of data generated by a autonomous vehicle. In addition to that, there's another example in terms of smart agriculture, where they use a lot of cameras and to capture images and compare that with the images in the library in order to help them improve the process. So with that, they have to, they generate 6 terabyte to 14 terabyte a day of data. So all this evolving needs or use case requires, first of all, more storage, more density in order to store all those data. Second, it needs to be very performant, where it can capture, store the data, and also access the data as fast as possible when they need to process them. And thirdly, on the edge, the environment is usually very rugged. It had to endure a lot of vibration, temperature change, etc. So solid state drive or flash drive seems to be the better or has to be the better solution than spinning disk in those scenarios. So not only in the on the edge, when we're talking about data center, there's also a lot of cases where larger density is needed. So when we bring all those pictures and videos from the field or from the edge to the data center, there needs a lot of processing of those. So for those, usually they are stored as an object, right? So the feature of object store is there are two major things. One is usually the object size is bigger, usually in kilobyte or megabyte of size. Second, for object storage use case, they are mostly read intensive, where they need access the data and process it, and less write intensive. So in a analysis done by Dell PowerScale, which is a solution provider for object store, they tested the QLC-based SSD, and they found that the QLC SSD projected a 14-year of drive life with a typical object storage case. So if you think about that, that is a long life, and that definitely will help with the sustainability compared to a hard disk drive. And on the other hand, it also shows you that flash drive, even QLC-based flash drive, is able to sustain for a long time for use cases in the data center. To further substantiate that, we have 3 studies done by University of Toronto, Storage Review, and NetApp. The first one shows that 94% of data center workload experience more read than write. And the ratio, the median ratio is actually 3.6 to 1. So data center have obviously grown to be more read intensive. Second is, this is a crunch the pie exercise with 100 trillion digits to generate the 100 trillion digits for pi. They use P5316, which is a QLC SSD, large density QLC SSD, to store all the digits. And they realized for this kind of computation intensive workload, the QLC-based SSD can provide a very good drive life for that. And thirdly, on the NetApp SSD study, they have done research on over 2 million SSDs, over 3 vendors and 4 years of data, and they found that over 90% of the SSD can be transitioned into QLC because their drive write per day rating can be lower than 1. And 1 is a typical DWPD rating for TLC, by the way, nowadays. So with that, let's look at the swimlanes for a typical data center SSD. So on the top, you have the 3 DWPD endurance SSDs. And at the bottom, and then second row, you have 1 DWPD. And the bottom, you have less than 1, about 0.5 DWPD swimlanes. Usually they are used for different applications. As I mentioned earlier, we see more and more use case in the data center that can move into the lower tiers for those read-intensive workload. And also at the same time, because of the lower endurance SSD typically come in a bigger density, bigger capacity, they can offer a much bigger PBW, which is petabyte write over the lifetime of the drive. If you compare a bigger drive with lower DWPD but bigger capacity with a smaller capacity but higher DWPD rating, you can see here with a lower the 0.5 DWPD, which is a QLC product line, they offers way more PBW over the lifetime than the higher rating TLC-based SSD. That means it allows you to write more data into the storage. And because it's a larger density, you can have less of them, so leave less of a footprint. So to further that point, here is a TCO analysis and sustainability analysis comparing using QLC-based SSD versus a all hard disk drive array and versus an all TLC-based array. On the left is a hard disk drive, on the right is a TLC drive. No matter what, you can see that the benefit of QLC-based SSDs because to achieve the same amount of storage and the same amount of performance, the 100 petabyte object storage cluster, QLC allows you with a 61.44 terabyte density to use less drives and thus less servers. With less servers, you need less racks and less interconnections and less power, or less maintenance, and all those good benefits. And in addition, in terms of power density, it's much higher in terms of power density. And in terms of power consumption, it's much lower to store the same amount of data or process the same amount of IOs. So in addition to that, at end of life, you have much less material you have to dispose of, which leave a much smaller footprint in the data center, and achieve more sustainability. Now, let's move on to a small exercise we've done. So what you see here is we done a model of a HDD-based cluster and a QLC SSD-based cluster. And we keep everything else the same. We vary some parameters and trying to find what actually impact the TCO and greenhouse gas emission the most. With this exercise, we found that the capability of doing inline data reduction, the capability of utilize the drive capacity more, the capability to use less redundancy or duplication in order to achieve the same level of reliability and reliability, and the less power it used by QLC SSD allows it to be a much better sustainable solution than traditional hard disk drive by 40 to 70%. So you are welcome to, so I leave a link over there where you can go to check out if, if you're interested, how you can use flash drive to achieve more greenhouse gas savings, as well as how you can choose smartly about different type of SSDs. So with that, I will pass it to Tim to talk about the rest of the agenda.
Thank you. So as we talk about sustainability, there are main areas, the first being the embodied footprint, right? That's a key aspect of it. And the other calculation that comes into play is related to actually the operational cost. So within operational cost, there's two factors. There's the actual power that the SSD consumes, and then there's the actual power that goes into cooling the SSD. So what this is focusing on is how do we enable a more sustainable platform? And the answer is kind of odd. It's a little counterintuitive, but it's actually to run the data center a little bit hotter. And what we mean is, okay, the best thermal design we have for an SSD includes the best, most efficient thermal solution, so it's making the most effective use of the air. And we're also driving the component capability in terms of thermal as high as we can go. So we're pushing the temperatures up, basically. We want to make sure they're still reliable, obviously, but there's another factor that comes into play, and this is what we're taking advantage of. It's called extended temp, but it's a feature that we've enabled. It's been enabled for every EDSFF and is now being enabled even for our U.2. The idea being that you could extend the touch temperature. The touch point has actually been the limiter in the form factors since it's been 70 degrees C, which is a legacy, a little bit antiquated 60950 spec. The newer spec that is being used today is 62368-1. That's the UL-EU spec. And that takes advantage of the fact that the likelihood of someone damaging their self by touching the surface, which does not need to be touched in order for the service to drive, is very low. We take advantage of that, plus the fact that we use instructional safeguards. We make sure that the consumer is aware it's a hot surface, don't touch. We also recognize that they don't have to touch the surface in order to service the drive. And so all of that leads to the ability to push our touch temperature up to 80 degrees C. So the table to the right is actually showing, it's actually to the left, but it's showing the benefits in terms of both the CFM per SSD, and then we're putting that in terms of, based on the airflow impedance. We're also calculating for you the kilowatt hour to operate the fans, and then putting that in terms of both the cost, and we're sharing some of the other parameters. Again, we really want to take advantage of this. This has been added to the 2.54 spec OCP. I saw it in whatever it is, the revision 38 that's going to be published very soon. So we're seeing that the 80 degree C touch is starting to become industry aligned, and we really have engineered a way to take the most advantage of this. So if you look, for instance, at a 25 watt U.2, the total cost of operation and essentially the energy is quite low. If you look at your EDSFF, there's a point where you do see a slightly higher cost of operation and essentially more airflow required, but that's because in this case we're doing 24 SSDs per 1U, which is enabling obviously more density, but you know, these things kind of balance each other. The calculation that we're using is a very standard calculation. We're taking advantage of the efficiencies, including, you know, PUE of 1.6. So the idea here is by taking advantage of this feature that we've enabled, running the data centers hotter, believe it or not, you could actually take advantage of cost savings and energy savings to operate the fans. Okay, so I'm going to hand it off to Michelle.
So another thing that we wanted to talk about is performance efficiency trends over time. So this is industry data taken from the past 7 years from SSD suppliers. So we just wanted to show the power efficiency trends for write and read power. And as we see, it is increasing over time. Performance has become more energy efficient over time. So we're looking at the efficiency, which is IOPS per watt or megabytes per watt. And as we see the red trend line, the performance is becoming more energy efficient over time. But as we look at that green line for power, we see that as the industry is going after generation to generation and doubling that performance of IOPS, we only see the power increasing about 1.4 times in comparison to that. So as we go from PCIe Gen 4 to 5 to 6 and more into the future, there's going to be an increase of performance demands from the industry, but we can only keep up in terms of power so much, as we see with that green trend line. So as we go into the call of action, we really just want to bring awareness about this topic and to look at the trade-offs when you are improving your platforms to see that if we are demanding higher performance, there is higher power needed as we go from generation to generation. So going right into the call to action, so as Yuyang was saying, we really encourage everyone to evaluate the conversion to QLC data center SSDs, whether that be from your HDD or TLC solutions, making sure that that's the right application for you. But we really encourage you to see that QLC is the way of the future and sustainable. And then as Tim said, to look at that extended temperature feature for our SSDs that are included in our SSDs, to take advantage of that thermal efficiency and to see the fan savings and data centers cooling costs that will save for your SSD. And of course, we all want to save a lot of money now, especially nowadays, but make sure you really look into the other drivers that affect sustainability, just looking at the replacement cycle or capacity utilization, just making sure that you are prioritizing sustainability and those drivers also aside from cost. So if you are interested more into looking at our QLC data center SSDs, we have that link on solidigm.com if you would like to see and learn more about QLC technology. And as Yuyang said earlier in the presentation, we also have our total cost of ownership and sustainability assessment link if you would like to go further into that and put in your baseline uses of your platform and your SSDs, and just making sure that you can see for yourself that QLC is the right way to go. You can put in your own workloads and then compare your baseline and then convert it to the QLC, and just to see how much that'll save you over time. And also look at the sustainability metrics and drivers and how much that will improve as you go into QLC. So thank you so much for listening to our talk today about sustainability.
Is it time for questions?
Yes, please.
Sorry, I had a dual question actually. So the first part, so I wanted to understand, thank you for talking about the density. I can now use it as an example when I'm up there. But I just wanted to understand, do you have some kind of a rate or a view on approximately how fast is the carbon impact reducing when you scale up the capacity? Is my question clear?
Yeah, so if you're referring to as the capacity increases, you use more die, and ultimately, so the embodied footprint calculation that we're trying to do has not been completed yet. There's a working group. We have an expert that has been trying to get that moving, and that's going to be something that we're going to have as part of the standard calculator. So that will be soon. We just did a very simple comparison here today, but the embodied footprint calculation will be part of the new calculator. So yes, it is a factor. We just don't know specifically what it is.
Well, I can address that if I may go back to the slide. If you look over here, you can see that we are comparing on the right, we are comparing a 30 terabyte TLC drive and a 60 terabyte QLC drive. So that's a doubling capacity, right? And in this case, we are saving 20% in terms of power consumption over 5 years. So if you translate that power consumption into carbon or carbon emission or greenhouse gas emission, you can get a ballpark of that amount of saving at least by transitioning from a higher doubling density SSDs. Obviously, there are much less servers and drives that's needed in order to, with a 61 terabyte SSD. So that further reduce the disposition at the end of the life, as well as the peripheral powers needed in addition to SSD for that purpose.
So in this comparison though, a QLC versus TLC, assuming it's the same layer count, we're talking about the same amount of silicon. So to move to the QLC actually gives you're doubling that density without that embodied footprint increasing in this case. Okay.
Just for the device, meaning just for the storage device, when going from 30 TB to 60 TB, for example,
right.
What is the amount of carbon reduction that you see? I was sort of trying to ask for that. If you have.
Yeah, in this comparison, they're equivalent for QLC versus TLC, right? The comparison back to HDD, that's where it's a little more difficult. There's a different comparison. There's different metrics involved. So that's where we need more time to collect that.
Okay, thank you.
Okay, if no more questions.
Okay, thank you.
Oh, is there one more question?
We have one more question.
Just one comment, because I
Yes.
have some data. I'm probably the last talk, so you probably won't be here. I do have some of that on HDD versus SSD, but the data I have on SSD is from that Dirty Secrets of SSD study that I question a bit. So forgive me in advance for using that, but that's the data I have. I'd love to see more data from you folks.
Yeah, thank you.